Welcome to our webinar. I'm Frank Mirecki, co-founder and CEO of Serve7.
And I'm Dan Perlman, Solution Architect.
Today we're diving into the self-service spectrum, when to use GenAI,
and when to keep it simple. If you have any questions during the presentation, please submit them using the Q&A function in the webinar platform. We'll respond to those at the end of the presentation.
Let me start with a simple truth. Customers don't compare you to your competitors anymore. They compare you to their last best experience. That might be a flight, booking a flight, ordering groceries, or getting tech support. And that's why customer experience isn't just a cost center. It's an engine for growth. Let's look at the numbers. Companies that prioritize CX are 60% more profitable, and 93% of customers say they'll buy again if the service is great. Here's the kicker. 31% of people say talking to someone knowledgeable matters most, but 20% just don't want to repeat themselves. So what does this tell us? People don't mind solving things on their own. They want it to be fast and easy and not frustrating, and that's the opportunity. Now let's talk about where the story often breaks down. Most businesses know they need to modernize, but the reality is they're stretched. There's not enough time, too much complexity, tight budgets, lean IT teams, and a moving target when it comes to optimization. So they wait, or worse, they duct tape legacy systems together and hope for the best. But let's be honest, that's like driving a horse-drawn carriage on a highway. You'll move, not fast, and definitely not safety. What's missing is a way to modernize without all the overhead, and that's where Amazon Connect comes in. Imagine a contact center built from the ground up with AI, one that's omni-channel from day one, voice chat, email, SMS, affordable with usage-based pricing, and backed by a partner like Serve7. We've walked this road before with over 20 years of CX experience. Amazon Connect gives you the tools to scale, automate, and personalize without needing a 12-month plan and a room full of engineers. This is transformational on your terms, and it starts with smart self-service. Let's rewind, 1962. That's when Bell Labs first introduced the IVR system. It was basic. Tones let callers choose an option. By the 1980s, it went mainstream. Press 1 for sales, press 2 for support, and it became the default experience. But it had limits. Menus got long, customers got frustrated, and businesses collected very little data. Then came the 2000s. Natural language understanding changed everything. Now callers could say, I want to check my balance, and the system would understand. It meant richer data, smarter workflows, but it was expensive. And that kept a lot of organizations on the sidelines. Fast forward to today, and we're at the edge of the next big shift, generative AI. This isn't about recognizing phrases, it's about understanding meaning, guiding conversations, and generating real-time responses. Thanks to cloud pricing, the cost barriers are gone. And now you can build bots that solve multi-step problems, personalize based on CRM and history, and detect emotion or urgency, escalating when it matters most. But here's the key, it's not all or nothing. Most organizations thrive with a spectrum of self-service. For FAQ or simple questions, keep it simple. For structured tasks like filling out a form or booking something, use a guided Lex bot. And for dynamic or unpredictable conversations, that's where GenAI shines. But why does this matter? Because today's customers expect to self-serve. Let's look at the data. 81% of people try to help themselves before contacting support. Done right, self-service reduces call volume by 30 to 40%. It speeds up resolution, lowers costs, and boosts agent productivity. And most importantly, it leaves your customers feeling capable, not stuck. So today we're going to walk you through that spectrum. From the peanut butter and jelly of self-service to the mission star experience of GenAI bots. We'll show you real examples, tools you can use today, and how to choose what's right for your contact center. With that, I'll hand it over to our solution architect, Dan Perlman. He's going to take us inside what Amazon Connect, Lex, and GenAI can deliver right now, structured versus open-ended.
Well, thanks, Frank. So as we discussed, self-service in contact centers spans a spectrum of interaction styles, from highly structured tasks to open-ended conversational problem solving. At the most structured end, we have defined workflows. These are step-by-step flows for predictable tasks like paying a bill, resetting a password, or checking an order status. The user follows a guided path, and the system knows exactly what to expect. At the most fluid end of the spectrum is agentic AI. Powered by generative models, this form of self-service can handle complex and open-ended issues. It can reason, retrieve relevant content, generate contextual responses, and complete tasks, just like a real support agent would. As we move from left to right along the spectrum, more advanced technologies need to be implemented to properly capture and process a user's request. But what exactly are these tools, and which ones should you be using for your business? Well, let's start with the basics. Think of basic self-service like making a peanut butter and jelly sandwich. Simple ingredients, easy prep, and almost anyone can do it. In the contact center world, this is your classic DTMF or keypad-based self-service. It's fast, predictable, and gets the job done, just like a comfort meal that you know and trust. Basic self-service consists of a few core building blocks. First, you can play a prompt. This could be a pre-recorded audio clip or dynamically generated using text-to-speech. And it's used to guide the user through a menu or play a message. Next, you can collect input using DTMF, where the caller presses keys on their phone to make a selection or enter a numerical value. This input can then be stored as a contact attribute so it can be referenced throughout the flow. Finally, you need to fulfill the user's request. This could involve playing an announcement or routing a user to the most appropriate agent, but even with basic self-service tools, you can still implement some automation. A great tool for this is AWS's Lambda service. It allows you to run a small piece of code in the cloud without needing to worry about servers or architecture. You just write the logic you need, and it runs automatically when triggered. This way, you can fulfill requests that require integrations to your backend systems. So what kinds of requests could you fulfill using just these basic self-service tools? Well, generally anything where you only need to collect numbers from a user. Bill payments, resetting a PIN, prescription refills, or checking an order status are just some of the tasks you could automate. You could also look at deflecting callers to web-based self-service tools by sending an SMS or email containing a link. All right, now let's show you what it looks like to build your first self-service flow. For those of you unfamiliar with the Amazon Connect admin interface, what you're seeing here is the Amazon Connect Flow Builder. It's a drag and drop visual interface that allows you to grab tools from the toolkit on the left-hand side and drag and connect them to create a flow. You can play prompts, collect information from users, connect to your backend systems, transfer to different flows, or set your logging or reporting preferences. What we've built here is a simple flow that allows a user to check their order status. And so let's go through some of the blocks that make this up. First is your play prompt, where you can type or add pre-recorded prompts to users. We have a menu here, which is your classic press 1, 2, 3, or 4 to get to where you want to go. But in this case, we're mostly looking at this option for press 3 to check your order status. Once they've done that, we need to collect and store some information from the users. So first, we have this get order number, which allows you to prompt a user for an input, which is then saved and stored in a specific contact variable, which is what we're doing in this set contact attributes block. Now we just need to confirm with the user that what they've entered is accurate and give them the option to confirm or enter a different number. Now that we've confirmed that the information we've collected is accurate, we want to connect to a backend system, and we can do this using a Lambda. We can use this to activate our check order status function and pass in the order number that we collected. Again, we want to save the output to a variable that we can use in the contact flow. And then we can play that back to the user as their order status. From there, we end the call. So now we're going to save this flow and publish it. Now we're going to call into the flow itself.
Thank you for calling Canoe Outfitters. Please select one of the following options. Press 1 for store hours. Press 2 to hear about our ongoing promotions. Press 3 to check your order status. Press 4 to speak with a member. To check your order status, please enter your order number, then press pound. The order number entered is 4486. Press 1 to confirm. Press 2 to enter a different number. Your order status is out for delivery. Expected delivery date is June 2nd before 5 p.m. Have a great day.
Now let's step it up a bit. Imagine a home cook with some skills. They know how to choose fresh ingredients and use real techniques to create delicious, well-balanced meals. That's what conversational IVR enables. Natural language processing is the secret sauce. It allows your system to understand what the customer says, not just what button they press. It allows for more intuitive, efficient interactions and delivers a more flexible experience. There are a few additional terms to know when discussing conversational self-service. In a conversational IVR interaction, an intent represents the goal behind a user's input. For example, if a user says, "What's my order status?" the system can match that to an intent like track order. Defining intents helps the system understand what the user wants to achieve. Utterances are the different ways a user might express a particular intent. For the track order intent, users might say, "Where's my package?" or "Track my delivery." By defining multiple utterances, you allow customers to speak naturally without needing to remember a specific phrase. Slots are the individual pieces of information the system needs to fulfill the intent. For example, to track an order, the system might ask for a tracking number or order ID. Those are the slots. You can configure additional phrases for your bot to use when attempting to elicit these slots. Amazon Lex is the AWS service that powers conversational interfaces like this. It's the engine that recognizes speech or text, maps to intents, extracts slot values, and integrates with backend services. It natively integrates with Amazon Connect to build voice-enabled self-service experiences. With conversational IVR, you can handle more complex requests where users speak naturally instead of pressing buttons. Users can more intuitively reach the self-service process they need, and you can collect words or alphanumeric strings as slots, which opens up a new range of self-service options. A few examples are processing a return, making changes to your account, submitting a claim, or completing a document. Because the system can understand intent and extract key details from what the user says, it's also great for routing calls more accurately or triaging support issues before involving an agent. And just like with basic flows, you can still deflect to digital channels. All right, now let's enhance our basic self-service flow to include conversational IVR. What you're looking at here is the Amazon Lex console. This is where you build and manage the bots used across services like Amazon Connect. I've created a bot for our electronic store menu to replace the old keypad-based flow. Let's take a look at some of the intents I've set up. Each numbered option from the original phone menu is now an intent. For example, if I open the store hours intent and scroll down, you'll see a list of utterances. These are phrases a customer might say, like, "What time do you open?" They all point to this intent. In the flow, this intent routes the user in the same way pressing 1 used to, but I've also added a new intent, which is check inventory. Inside that intent, we still have example utterances, like, "Do you have this in stock?" Once Lex recognizes the intent, we ask for a couple of slots. These are specific pieces of information that we want to capture. We're collecting the product name and model number. Product name is a free-form input, so the user can say anything. Model number is set as alphanumeric, since it's usually a single string of letters and numbers. Once we've built and saved the bot, we plug it into our flow. Let's compare the old and new versions. In the basic self-service flow, we play a prompt and use a menu block. The caller presses 1 through 4 to choose. In the conversational flow, we start with the same prompt, but instead of a DTMF menu, the Get Customer Input block now uses Lex, specifically the bot we just created. Based on the intent Lex matches, the flow follows a path. For intents like store hours or promotions, the logic is the same. We just respond differently based on what the customer says instead of the key button that they press. Now, let's look at our new check inventory intent. When the LexBot finishes, we already have the product name and model number captured as attributes. From there, we run a Lambda function to check store availability. Then we play an announcement with the result. If the product's in stock, we can also ask the customer if they want us to put one on hold for them. Let's go ahead and test that live.
Thank you for calling Canoe Electronics. How can I help you?
Hi, can I check store inventory?
Which product are you looking for?
Sony TV.
What is the model number?
K55L20.
The Sony TV K55L20 is currently available in store. Would you like me to put one on hold?
Yes.
I have put the Sony TV K55L20 on hold for you. Please pick up your order within 3 business days. Have a great day.
At the highest level, imagine a professional chef crafting a custom dish in a fine dining restaurant. They adapt in real time to what the diner wants, even if it's not on the menu. With premium ingredients, refined technique, and a strong team working together, you can deliver truly memorable experiences. That's what generative AI brings to the table. It's flexible, adaptive, and elevates self-service to something customers didn't even know was possible. There are, again, a few terms we need to understand before building our first AI assistant. First up is knowledge bases. When using AI to answer open-ended questions like, how do I reset my device, or what's your return policy, the system relies on a knowledge base, a structured set of documents or FAQs that the AI can reference. These aren't traditional scripts. They're real business content that the AI can pull from using retrieval techniques. Your knowledge base articles can be stored in Amazon S3 or a CRM like Salesforce or ServiceNow. To make this work well, you need to structure your data carefully, and there are a few key best practices. You want to use clear, concise language, break content into small focused chunks, ideally one topic or question per entry, avoid large blocks of text, group related topics together using headings or metadata like categories or product names, and make sure you keep your documents up to date. The better your data is structured, the more accurate and trustworthy the AI's responses will be. Now we need to define how the AI interprets and processes an input from the user. That's the role of prompts and guardrails. A prompt is a set of instructions or context you give an AI model to help it understand how to respond to the user. It defines the tone and persona of the AI assistant, provides instructions and examples for the assistant to follow, and sets rules for the AI's responses. A prompt may instruct an AI assistant to respond directly to a query, but may also instruct the assistant to use a tool. A tool is an external function or API that the assistant can call when it needs to take action beyond just replying with text. We pair this with guardrails. Guardrails are a set of policies that help you control what the AI can and can't say or do. For example, you might want to block sensitive topics, prevent sharing outdated information, or ensure that responses are grounded in relevant source material. Let's walk through what goes into constructing a prompt. For the solution we're building, we actually need two prompts. One to select the right tool for handling a user's request, and another to generate the final response when using the knowledge base. We start with a system prompt. This sets the overall tone and persona of the AI assistant, like how it should speak and behave during the conversation. Next, we define the available tools. For example, we have a check inventory tool, which is triggered when a user wants to confirm if a product is in stock. This tool calls a Lambda function to complete the request. Then there's the question tool, which is used when the AI can answer using content from the knowledge base. This one relies on a second prompt to help generate a useful, well-structured reply. Prompts can also include example conversations to help guide the AI's behavior. These aren't scripts. The AI doesn't need to follow them word for word, but they provide helpful patterns that the assistant can learn from. Finally, we give the assistant a clear set of instructions, what inputs it will receive, what it needs to do, and how to decide if it has enough information to select a tool. If it does, it picks the tool and ends the session. If not, it keeps the conversation going to gather more details. For the response generation prompt, we follow a similar structure, starting with defining the tone or persona of the assistant and outlining the inputs it will receive during the interaction. Next, we include a detailed set of instructions. These tell the assistant to first verify that request is safe and appropriate, in other words, not malicious. Then it checks whether it has enough information to generate a meaningful answer. Finally, it confirms that the response can be grounded in the provided source material. Only after those checks does the assistant move on to generating a reply. These are just sample prompts, but they illustrate a key point. Writing a good prompt is one of the most important factors in delivering an effective AI assistant. A well-crafted prompt can be the difference between a clunky, confusing experience and one that truly feels intelligent and helpful. Next, let's talk about guardrails, the safety and quality controls that keep your AI assistant aligned with your business standards. Depending on the platform that you're using, there may be an admin interface to help configure those settings. Here are a few key options. First up is content filters to help block harmful categories like hate speech or harassment. And prompt attack protection adds another layer of security by making it harder for users to trick the AI into saying something that it shouldn't. You can also define custom denied topics if the built-in filters don't go far enough for your use case. If there's a risk of users sharing personally identifiable information, you can mask or block that content automatically. And finally, you can set up a grounding threshold. This ensures the AI's responses are relevant to the user's query and based on trusted source material. Together, these guardrails help you deliver accurate, responsible AI interactions that protect your brand and your customers. Now that we've got all of our inputs and our instructions, we need to craft our responses. This is done using a large language model, or LLM, and supported by Retrieval Augmented Generation, also known as RAG. LLMs are advanced AI models that can understand and generate natural language, meaning they can read and write like a human. With Amazon Bedrock, you can access powerful LLMs like Anthropic's Claude or Amazon's own Titan model without having to build or train them yourself. This makes it easy to build chatbots that can handle open-ended questions, summarize information, or respond in a way that feels conversational and human-like. Once your content is indexed in a knowledge base, you can apply a technique called Retrieval Augmented Generation, or RAG. This approach connects your documents to the AI in real time. So when a customer asks a question, the system first searches your indexed content, finds relevant snippets, and then passes those snippets to the LLM to generate an accurate, personalized response. With generative AI-powered self-service, you can handle open-ended, unstructured requests that go beyond predefined intents and menu options. Users can describe their issue in their own words, even if it's complex or hard to categorize. And the system can still understand, reason, and respond helpfully. This enables advanced use cases like troubleshooting a product issue, providing outage support, recommendations, or resolving a complaint. Generative AI can also summarize information, rephrase it for clarity, or adapt responses based on context, creating more natural, human-like interactions. So, we've gathered all of our components, or our ingredients. Now the question is, how do we bring it all together? This diagram shows a sample architecture for a conversational AI flow. A customer calls into Amazon Connect, which triggers a Lexbot to handle the conversation. A Lambda function acts as the bridge, connecting Amazon to Bedrock for access to knowledge bases and large language models. From there, you can plug into additional services like Amazon Translate, OpenSearch, or Kendra to expand capabilities even further. The possibilities here are incredibly powerful, but they also come with complexity. It's like running a full professional kitchen. You'll need a skilled team and a clear recipe to make it all work. So the next question is, how do you even get started? Well, imagine a restaurant offering a reduced menu tasting night. There's fewer choices, but lower cost, and still the same world-class kitchen, expert staff, and premium ingredients behind the scenes. Diners don't have to choose from a long list or worry about what to order. The experience is curated and still delivers the quality and care of a fine dining meal. It's a way to lower the barrier to entry while maintaining the essence of what makes the experience special. For many, it's the perfect introduction to gourmet cuisine. Less intimidating, more approachable, but just as satisfying. That's what a package solution like Q and Connect offers. It delivers the power of generative AI, knowledge integration, and tool selection, but in a simplified, pre-configured format that lowers the barrier to entry. You get advanced AI-driven self-service without needing to build the solution from scratch. For our last demonstration, we're going to walk through the process of creating an Amazon Q Assistant, connecting it to a knowledge base, integrating it into a contact flow, and finally placing a live test call. We'll start with the knowledge base. In this case, I've created one using a simple Amazon S3 bucket, where I've uploaded a PDF with some product troubleshooting tips. But Amazon Q also supports other data sources, like Salesforce or ServiceNow. Next, in the Amazon Connect console, we create a domain. The domain defines the data source. Here, I'm using the S3 bucket we just set up. Once the domain is configured, I need to create a Q agent and define the prompts and guardrails for that agent. For this demo, I created a prompt called Canoe Outfitters, which includes tools for things like order status and handoff, along with example conversations to help guide the assistant. I also set up a guardrail to ensure the assistant stays within the topics and behaviors we want it to support, filtering harmful content and keeping responses grounded in our knowledge base. Now that we have the prompt and a guardrail, we assign them to an agent, in this case, our AI assistant. This agent uses those configurations when handling user interactions in self-service flows. Now let's switch over to the contact flow. In our earlier conversational IVR flow, we used a Lexbot to capture utterances and determine intent, then routed the call accordingly. In this new AI-powered self-service flow, the structure is similar, but with two key changes. We use an Amazon Q and Connect block to connect our Q assistant to the flow. We then use the same get customer input block, but instead of using a standard Lex bot, we use one configured with the queue and connect built-in intent. This setup allows the AI to process multi-turn conversations, reason the user's intent, and choose the right tool, all within that one queue and get customer input block. Now, when I call into this flow, you'll notice that it stays in the get customer input block for a longer time. That's because it's having a richer and more dynamic conversation. When it determines that a tool needs to be used, for example, the order status tool, it writes that decision to contact attributes. Then, using the check contact attributes block, we identify which tool was selected and follow the appropriate path. In this case, the fulfillment paths are the same ones that we used in the earlier flows. Using Amazon Q or an AI assistant, we can simplify further. For example, instead of building dedicated flows for store hours or promotions, we could simply add that information to our knowledge base and let the assistant answer those questions directly. For actions like checking an order status or inventory, we still need to invoke Lambda functions to talk to backend systems, and that part remains in your flow. Now, let's place a call in and see it in action.
Thank you for calling Canoe Electronics. How can I help you?
Hi, my TV turns on, but there's no sound. Is there any way to fix that?
Let me look into some troubleshooting steps for no sound on a TV. To troubleshoot no sound on a TV, first check that the TV is not muted and the volume is turned up. If there is still no sound, try unplugging any headphones or external speakers that may be connected. If the sound issue persists, try restarting the TV by unplugging it for 30 seconds and then plugging it back in. If that doesn't work, you may need to contact support or request a repair.
Okay, thank you. On another note, can I check an order status?
Sure, I'd be happy to check the status of your order. What's the order number or other details I can use to look it up? Enter your order number, then press pound. The order number entered is 2246. Press 1 to confirm.
So I'll end the call there. As you saw, the assistant handled the troubleshooting questions directly when using the knowledge base. When I asked about my order status, it identified that I needed it to use a tool, selected the order status tool, and routed the call to the flow for fulfillment, just like in the very first demo. Now, you can keep enhancing other parts of this IVR flow with additional conversational features. You could have the AI assistant collect information up front, or simplify entire parts of your flow with just knowledge-driven responses. Again, though, for those back-end integrations, you will need to exit those flows and use a Lambda function. It's all about how you want to balance the collection and the fulfillment logic across your architecture. Let's wrap things up by revisiting our cooking analogies and what they tell us about the different levels of self-service. We started with the peanut butter and jelly sandwich. Simple, fast, and reliable. That's your classic DTMF self-service, where users press buttons to navigate a menu. It's easy to build and maintain, but it's limited in flexibility and scalability. Next, we moved up to home cooking, using natural ingredients and real technique. That's conversational IVR, where users speak naturally and the system understands intent. It creates a more intuitive experience and opens up new options like collecting words or phrases and helps route calls more effectively. Then we stepped into fine dining, where a professional chef crafts a custom dish based on what the user really wants. That's generative AI-powered self-service. It's flexible, adaptive, and capable of resolving complex issues by understanding content and pulling knowledge from sources or backend tools. Finally, we looked at the reduced menu option. Fewer choices, lower barrier to entry, but the same kitchen and staff behind the scenes. That's Q and Connect, a pre-packaged, fully managed version of generative AI self-service that gives you advanced capabilities without having to build everything from scratch. Each of these self-service models has its pros and cons. DTMF is fast and reliable, but not user-friendly for complex tasks. Conversational IVR improves the experience and supports more use cases, but requires more effort to design and maintain. Generative AI delivers the richest and most flexible interactions, but it's also the most complex to build. Q and Connect strikes a balance, giving you much of the power of AI with significantly less development effort, but with some constraints compared to a fully customized build. At the end of the day, every business is different, with unique customers, systems, and goals. We hope this overview gives you the clarity and confidence to choose the right self-service approach for your organization and the tools to start building it.
Thank you for joining us today. We hope you found our presentation informative and entertaining.
And thank you for submitting your questions. We'll be answering those in the Q&A now. If we don't get to your question, we'll follow up with an email.
If you want to find out more, we've included links for scheduling a free CX discovery session. It's a great opportunity to start your journey towards better CX.